Good evening to all.
Good evening, sir.
I think all of you have joined now. Can you see my screens?
Yes, sir.
Okay. So I think your 2 AutoCAD sessions are done till now, isn't it?
Yes, sir.
Okay. Yeah, so all of you, are you aware of the engineering drawing basics? Actually, see, as we are doing the practical training program along with the softwares, it doesn't mean that we can forget our engineering basics which we have learned. So in the beginning of the sessions, training sessions, we will be having some conceptual training sessions before going for the software training program, we can say. So today, actually, we are going to discuss more about the drawing basics and what you know about that. So important point I would like to highlight today is regarding the drawings. See, even though we are learning nowadays the new technological technology and we are using different softwares for the drawings. So what softwares are used for the drawings? Anybody? What kind of softwares do we use for the drawing preparation?
SketchUp, and
Yeah.
AutoCAD, REVIT,
Yeah.
3D Max.
Yes. So we have the softwares which are first is the classical software which we got actually initial draw software which we can say it was the AutoCAD, which is 2D drawing software mainly. It can do the 3D also, but mostly it is used for the 2D drafting. So, and do you know Revit nowadays it is used for 3D and 2D drawing extractions. And there is one more software. Do you know this software MicroStation? Hello.
No, sir.
Generally,
No, sir.
American projects the people use most of the times. America, Canada, these countries. But most of the times, these two softwares are very popular actually, and that's why we have introduced it because most of the sectors and most of the countries use these softwares only. So that is why we have introduced this. AutoCAD is definitely a classical software, we can say. It is worldwide use and it has been used since long actually. And even though the technology is growing up, still AutoCAD is having its importance intact. Then there are many other softwares, but they are not yet much popular, and so it's no need to think. Regarding the 3D modeling, we can say generally TEKLA software is used for steel drafting, steel detailing, we can say. Then there is, we can say, Google SketchUp, which is used for the modeling. SketchUp, 3D modeling, we can say. There are some softwares which are like 3D Max, but they are mostly used by the architects. For it's a rendering, good rendering software, we can say. 3D models and let's say rendering. These are the softwares nowadays widely used. I'm just putting, there are many other softwares also, but these are quite popular softwares, we can say. Out of this, we are going to cover these two softwares, which are mostly used as far as the market share is concerned. Regarding with respect to different companies they are using, most of the people are using these softwares. So that's why we have introduced this in our training program. Now, the most important point regarding the drawings, that is nothing but our hand sketching. Whatever maybe the softwares come, whatever maybe the technology is coming, you cannot ignore this sketching by hand. This is highly important and you should not forget at any moment. I would say that even though you forget one of the softwares out of this list which I listed, doesn't matter. But don't forget sketching by hand. So many people may be finding difficult to draw the sketches by hand, but you should have the at least habit of drawing the sketches. Engineering sketches, I'm not saying that you become the artist like painter or say sketchers, but at least engineering drawings, many times people find difficult to draw the drawings on the plain paper. But in engineering, we can use square rule pages where you can get the reference and you can draw good sketches. And one of the important point that, see, even though we know the softwares, different software, it doesn't mean that you can read the drawings. So drawing reading is a different skill and understanding the drawing is a different skill. Even though you know the AutoCAD, even though you know the Revit, it doesn't mean that you know the drawings. See, drawing, reading, and understanding is a classical point, and only an engineer can do this. No other softwares can read the drawings. It can draw the drawings, but cannot understand. See, understanding is a term which is related with the human beings. Even sketching can be done by the engineer only, and not by the softwares. Okay. So these are used generally for the conceptual sketches, I would say, conceptual sketching, because for detailed drawings, we have the softwares and we will use it. So conceptual sketching is a good thing. Here, actually, conceptual means we develop our thought process, we develop our concept before drawing any drawings in the softwares. So conceptual sketching is one of the important point. So even though you are learning AutoCAD now and you will be learning Revit sometimes in future, it doesn't mean that you should forget the sketching. So I would suggest all of you start sketching now. See, even though you are less in softwares, it doesn't matter. It doesn't make any much difference as far as your career is concerned. But if you are weak in sketching by hand, then it may have the issue. Drawing reading, I don't know how many of you can read the drawings. Reading drawings means and say 3D view, understanding the 3D view, then understanding the 2D views, dotted lines, center lines, and so on. So what we learned in the first year of engineering. So drawing reading, many people, engineers find difficult, but you can develop that skill by practice. So this is also one of the
Hello.
important. Other softwares, yes. Hello.
Sorry to interrupt, sir. Sir, some people are waiting in the lobby, sir. Please allow them.
Okay, they are calling. Just a moment. Sandeep, are you there? Just a moment. New class going on. Amarjit is finding difficulty. Is it trying? We are having that link on the WhatsApp group also in the description. Just a moment. Hello. Yeah, Sandeep is trying to connect him. Actually, there is some issue with Amarjit, I think. We'll continue. I'm just briefing you the basics in the beginning. Okay.
Yes, sir. I'm working on that, sir.
Okay. No issue. No issue.
No problem.
Yeah. Yeah. So these points are very important. Okay. As we are talking about the sketching, then definitely we should know that what are the paper sizes available, and see how many of you have really tried the drawings on the drawing sheets. Anybody? Just let me discuss with you. How many have you really drawn the drawings on the drawing sheets
Sir, in engineering college, sir.
in the engineering college? And those who are in practicing, have you drawn any drawings till now? So you did the drawings in engineering college, or you did the GTs? I think GT word is common to all of you. Okay, so do you know what are the paper sizes? Anybody knows what are the paper sizes which we use for the printing?
Yes, sir. I know.
Yeah, please. Vijay Yadav.
Yeah.
What are the paper sizes? Just let me know.
A4, A3, A2, A1, A0.
Yeah, A3, it starts with A4. So generally, whatever we use for the documentation,
Hello?
report preparation. Yes.
Sir,
Yes.
no voice coming out, sir. Hello?
Am I audible to all of you clearly?
Yes.
Yes, sir. Yes,
Okay,
sir. Yes.
okay. So A4, A3, A2, A1, and A0. These are the paper sizes available. A4 generally we use for the documentation. I think this paper all of you know. Those who are working in the, we can say, consultancy offices, or those who are working on the sites, they may be aware of these paper sizes also. A3 is almost double of the A4, we can say. So let's say in A4, 210 is the width, 297 is the length of the paper. In mm, I'm talking. Then A3, so 297 means its length becomes here width, and then 420. So these are the paper sizes available, and mostly on site this size is very popular for bigger projects, we can say. Not this A1 I'm talking, just a moment. A1 is most popular on the sites. So as you are say learning the AutoCAD, actually final output goes to the site which is on the paper itself through printing. That means you should know the paper sizes also while doing that. Because what is the benefit of AutoCAD? Can anybody tell me why we are learning AutoCAD?
For drawing purpose.
For?
Drawing purpose.
Yeah, we are drawing, but why can't we use the hand drawings?
Sir, we can correct
Detail
easily. Is there any...
purpose.
Sir, we can correct easily, sir.
Yes. Yeah. Actually, why softwares we use, the most important point in the software use is why we use softwares, because it is saving our time actually. It's very fast. Softwares saves our time. That is most important point. That means we can finish the project within very less time, and it can do reworking very easily. Reworking. So what is reworking? You can understand easily, and it can be reused. So let's say you have done old project before. So you can use that old project as a reference, and you can just match the properties and copy paste the same things which are required for your new projects. So this is the important point why we are using softwares, and that is the benefit of the AutoCAD also. So it can save the time, it can do the reworking easily, and it can be reused. So reuse means old projects, old standard projects we can say. So this is the important point. So if we do the things on the drawing by pencil and pen, definitely I cannot reuse, because for new project I need to again do the same drawing from zero. I cannot do the reworking easily because I cannot delete the things, because once I do it by pen, ink pen, then it is finished. We cannot erase it easily actually. It's very difficult. So that is the benefit of the softwares, and we should know that. But what is the difference in softwares and this conceptual sketching? Softwares cannot think, and that's why hand calculation or hand sketching is useful for our understanding and thinking. So these are the papers which are used on the site for drawings. Whenever we do the drawings in the consultancy offices, we use these drawings. So if the drawings is very small, we can use A4. If it is little bigger than this, then we can use this. And generally these are the sizes, common sizes used. If our drawing is quite bigger, like survey drawings, so you know that contour drawings are very big because they're having major area to be covered on the paper. So we can use A0 size also. It is rarely used, generally used by the surveyors. Now I would say this is have you any time measured the size of the paper through the scale? Anybody? Have you tried to see the dimension of the papers by using scale on your own? Hello?
No, sir.
Yeah, so that is actually, so what I'm trying to say by this, so as you are people working in the practice, or you will be working in the practice if you are a beginner or fresher, see, use the scales, use the tools by your hand only. Verify that, see, I'm seeing as a trainer, what I'm talking with you, that these are the paper sizes. You should not only remember or just believe me that I'm saying this. If I say that A4 size is a 210 by 297 mm, you should take the scale, take the paper and measure it. You should not believe anybody blindly. So that is first, I would say, mantra today. Don't believe anybody blindly. You verify it and then you can believe on that. So even though I say something, you should try on your own. You should try to understand whether I'm saying is appropriate or right. Verify it, and then once you verify it, then it is no issue. Then we are at the same page. So when see, as a civil engineer, it is a common we can say field, common sense field, and there are many times we can see the projects, we can see the structures, we can see the objects. Take a measuring tape and measure it. Let's say if I say that seal level is 0.9 meters, or if I say my lintel level is 2.1 meters. Don't only believe on me, just take a measuring tape, go in your home and measure the door height or lintel height. If I say the door height is generally 2.1 meters, so you should measure it. What is exactly 2.1 meters, or it is less or more? So that practice you should do, so you can learn a lot of things through observations and through your own exercise. Okay, so this is the, actually you can see on the paper, I have measured this by the scale 210 mm and 297 mm. This is one of the important point I want to highlight, that you should measure it now. Definitely in drawings, our aim is to draw civil and structural drawings. As a civil engineer, most of the times we are using civil drawings, structural drawings, architectural drawings, and in general we can say. So what are the units we use in engineering? Anybody?
Generally, some meter.
Yeah, generally meter,
Correct.
which, yeah. So we,
Feet and inches.
And inside in practice,
yes, pardon, please.
inside practice, we generally use feet, sir. Feet.
Yeah.
Feet and inches.
Yeah, so generally on local sites, we can say smaller sites, generally people use feet and inches. The general carpenters, the general language of the carpenter is feet and inches most of the times. Or if the small projects are there, the contractor is also using the feet and inches. Let's say you may be aware that people, if I ask you, what is the your living room area? So many people say it is around 150 square feet or 200 square feet. Or some people, if I ask you what is the plot area which you have, so the people say I'm having 1000 square feet plot area. So square feet, square inch, or say what is the height of the door? 7 feet. What is the tile size? Vitrified tile you are using at home. The people say 2 feet by 2 feet. So many times in local language and smaller projects, people use in feet and inches. And in engineering colleges, we have learned meters and millimeter unit mostly. So as these two units are there, and many times through engineering, we learned only meter or many times centimeters also. We are not aware of the feet inch system. And as a civil engineer, definitely you should also be aware of the feet inch system. So if you don't know what is feet inches, you should understand. So can anybody tell me what is, how much is 1 feet?
12 inch.
12 inches. 12 inches. How much? 1 inch means how much millimeters?
25.4 millimeters.
25.4 millimeters, right? So these are the quite common units and unit conversions you should know. It should be by heart, and if you don't remember, at least you should have your handbook ready to understand these units. Now scale. Now we have to understand what is scale. So why we are drawing the drawings on the paper? Can anybody tell me? Let's say I want to draw a plot on the paper. Why I am using the paper? And what is the use of scales? Do you know what is scale?
Yeah.
Please.
Scale to fit the project into a proper place, sir. We generally use a scale.
Yes.
Sometimes the dimension is very bigger, then you have to use a scale to fit in a proper paper.
Yes. So if I ask you, draw 5 meter by 10 meter plot, it's a plot size on the paper with scale 1:1000. Can anybody draw this? Let's say start with the 1:100 first. Okay. If I ask you to draw 5 meters by 10 meters on a A4 size paper to the scale 1:100, can you draw it?
Yes.
How will you draw it? Or what do you mean by 1:100?
1:1. That means whatever the dimension is given, it is plotted in the same proportion.
Okay, so see,
1 centimeter is equal to 100 meter, maybe.
1:100. Let's say, what is 1?
One is, sir, for 1 unit we have taken in drawing 100 units. Assuming for 1 unit equal to 100 units. Suppose that
1:100. What is 100? What is 1?
1 is the
Hello,
Hello, yes.
sir. 1 is the drawing distance, and 100 is the actual distance in the site.
Yes. So that means, let's say our paper is, my paper size is how much? A4 size paper I am talking currently. How much is the paper size? 210 mm means how much meters? Okay, let's say 5 meter by 10 meter is what unit? In mm? Meter to mm, how much is this?
5,000 into 10,000, sir.
5,000
5,000 into 10,000.
into 10,000 is my, so this is my mm, this is my mm. Okay. So, okay, so this is on the site. So this plot is always on the site. Can I fit 5,000 mm on 210 mm?
No, sir.
200 by 297 mm. I cannot fit this, right? That means what I have to do? I need to do this. I need to scale it down, right?
Yes, sir.
So I have to divide that dimension. Now let's say, now our aim is, can I fit my 1 is to say this plot size on A4 paper using these units, okay? So what is this? 100 is on the site, right? So let's say if 100 mm is on the site, that means 1 mm is on the paper, right? Do you understand? It's very easy, na? If the dimension on the site is 100 mm, I will draw on the paper as 1 mm and I will write below the paper 1:100 scale. Correct? Now tell me, for 1:100 scale, how much dimension, 5000 dimension will come on the paper? Yes?
5 centimeter into 10 centimeters.
No, see, yeah. So, see, many people
5 centimeter cross.
don't use different units. Use same units. Don't say centimeter.
Okay, sir.
I have not used any centimeter
Okay, 50.
now. Yeah.
Okay, 50 mm into 100 mm.
Yeah. So what I'm doing actually, say, let's say this is my 5000 and this is my 10,000 plot size. When I say this is 100, that means I need to divide it by 100, right? To convert it in on the paper, right? So how much is this on the paper? So the 5000 is side divided by 100 is how much? 50 mm.
50.
This is also mm, na? By
Yeah.
100 mm, right? So this I need to draw on the paper. So 50 mm, how can you draw 50 mm on the paper using scale?
Scale.
So take a scale like this. Yes. You know how to use the scale. This is a scale. So 50 mm, can you just tell me what is 50 mm over here? Can you see this 50 mm?
Yes, sir.
Yeah. So can you show that 50 mm to me? So let me erase this first. Okay. Yes. Where is 50 mm? Imagine it, you are drawing on the paper. This is a paper only, real paper. Only I am using the screen, that's why. Where is the 50 mm? Do you know what is this one indicates?
Centimeter, sir.
Yes, sir.
1
Centimeter.
centimeters means how much
Then
millimeters?
five-
How much?
then five- then 5
10 mm, 10 mm.
millimeters.
10 mm. This is nothing but 10 mm. This is 20, 30, 14, 50. This is my 50, right?
50.
Yes, sir.
Correct.
Yes.
So this is my 50. So I will draw a line of 50 mm because I want 50 mm on the paper, right? Then 100 mm is this much.
10
Till this.
millimeters.
So let's say now I don't have the scale with me, but let's say this is my 100 mm, correct? And now this is my, so this is my plot size on the paper. And what will I write here? I will write over here as 1:100 below this. Now, what is this dimension? Whenever I draw a dimension on the paper, what dimension I write? Will I write 50 mm or 5000 mm on the paper?
On the paper, 5000 mm, sir.
5000 only, because this dimension on the paper indicates side dimension only, but if you scale it, you will see only 50 mm because it is 1:100 scale, right? So this is the meaning of scaling. Getting?
Yes, sir.
This is
Yes,
very important aspect, because many times we can understand the AutoCAD very easily, but sometimes we forget the basic concepts, and then it is not good. We should have the basic concepts and AutoCAD together. So this is the point which we want to learn out of this. Now, if I say same plot I want to draw, but 1:50 scale. Okay. My plot size is same, 5000 by 10,000. But now I am asking you to draw this plot size with 1:50 scale. Now, how much
Yes,
on the
sir.
paper it will? Yes.
So it's 10 by 20, sir.
So what is the procedure?
10:20.
See, now you are giving me the answers. Definitely answers are important, but I generally don't like to get the answers directly. What is the procedure? How you are arriving that number? The process is very important.
Just
Directly we
dividing
divide
5,000 by 50, sir.
Yes, that is
both
the
sides.
process.
We divide with 50.
Divide by 50 because when you divide it, the dimension is less. Then how much is this?
Sir, 10, sir.
10:20.
20:20. And in mm, don't forget to write the units.
Yes, sir. Amen.
Yes. Okay. See, I'm just putting some important points because these are the points which may confuse us whenever we do other things. Means it. This is my 10. Now here somewhere my line will come. Right. You can see this 10. And my 20 will be little longer. I don't know where it will come. And then at the below point, I will write is as a 1:50 scale. And what dimension I will write over here on the paper?
So 5,000.
Yes, 5,000.
5,000
Side dimension also. Only side dimensions we write on the paper, right? So this is my. But this scale I will write as a scale is equal to 1:50. So this is the scaling concept, which is very important. When the consultant gives the drawing, if they print it to the scale, then you can scale it by using this scale to understand. Many times what happens on the drawings, we don't get the dimensions as given by the architects or consultants. So you can scale it, use this scale and just measure it for approximate understanding. Okay. So this is the concept of scaling. Now I would, this is a small assignment to all of you, 5 meter to 10 meters. Please draw the, now tell me how much will come as a 1:1, how much, 1,000. So let's say 10:1, 5 meter by 10 meter, I want to draw on A4 size, scale 10:1. What is meant by 10:1?
10 means we have 5 meter convert 50.
First point is always say, when I say 1:100, then it is, this is site, this is paper, right? Now when I say 10:1, same. One is site, 10 is paper. So if I ask you to draw the same plot, 5,000 by 10,000 on the paper, to this scale, will it be possible?
No, sir.
Just not possible, right? So have you seen this kind of scales that paper is giving more scale and site is less? Any idea? Sorry.
No.
Have you come across this kind of dimensions before? No.
No, sir.
Okay. We'll discuss. Okay. So for you, I'm having one exercise, small exercise just. See, for understanding, we need not to do something very rocket science or something complex things. Simple things are there. Concept is only lying within the simple things only. So draw 5 meter by 10 meter plot size on the paper using these scales. General scales are used are 1:1000, 1:500, 1:100, 200, so on. Okay. 1:1000, where this scale may be used?
So contour survey, plot surveying.
Yeah, when the dimension of the site is very, very huge, right? That means, let's say I'm asking you to draw, the plot size is 1 kilometer. 1 kilometer is how much? 1,000 meters.
1,000 meters. Yes.
By 2 kilometers, 2,000 meters. Okay. Now tell me, what scale will you use to draw this plot on A4 size paper, this paper only? Tell me. Yes, tell me.
Sir, by 1:10,000.
Okay, let's try. You see, we can. we cannot get the answer exactly at first trial. 1:10,000 you are talking?
Yes, sir.
So let's say 1,000 divided by 10,000, right?
Yes, sir.
And 2,000 divided by 10,000. Let's try this. 10,000, na?
Yes, sir.
So how much will this come? This 3 and 3. So it will be 0.1 meters by
0.2 meter.
0.2 meters. So see, on paper generally we can use millimeter. So how much 0.1 meter is on the paper?
10.
100 mm,
Yes.
right? So, and what is the width of paper? 210 mm. So definitely 10 mm is possible. So your scale of 1:10,000 is good choice. You can draw it by 10,000, right? Are you getting me what I'm trying to say? How to understand the scales?
Yes, sir.
It's very easy. So either you can draw a plot. That means, see, where we get this kind of dimension 1,000 meters. So definitely when you do the survey, control survey, or road survey, then we get a lot of bigger dimensions. Road survey, we are in kilometers. We are doing in kilometers. This is 1 kilometer by 2 kilometers. So in that case, I need to use bigger sizes, scales, or I need to increase the size of the paper. Now, if I ask you, now what is your plot size is coming over here? Let's say using 1:10,000, that means 10 is here. So that means my plot will be like, so see, this is my 10 by, let's say this is my 20, correct? That means it can fit into the A4 size paper. Now, if I ask you, I want on, say 1:10,000, 1:5,000, or 1:2,000, let's say 1:2,000. Can you draw it by using this scale, 1:2,000 on this paper? On this paper, can I draw 1:2,000 scale? So what will be the paper size dimension on the paper? 1,000 divided by 2,000. So how much is this? Yes?
0.5
0.5 meter by, let's say 1 meter, right?
1 meter.
Means mm means how much? 500 mm by
1,000.
Okay. So can I fit this? Because my width is 210 mm and it is asking for 500 mm. So it cannot fit. What can you do?
We have to reduce the scale.
Either scale you should divide it, let's say go to 5,000 or 10,000, or what can you do?
Change the paper size. Increase the paper size.
Increase the paper size, yes. So what is the paper sizes available? So there are two choices. Either you can increase the scale or increase the paper size. So how can I increase? What are the paper sizes available? 841 by 1189. So I can use A0 page and I can use that scale, right? Getting? So this way we can use the papers for drawing the purpose. So actually you are learning the AutoCAD, but AutoCAD will not let you know what to do, how to decide the paper sizes, how to decide the scales. That we can decide. So that is the reason why I'm just taking this example. Okay. Now, can anybody tell me, when you draw on the AutoCAD that black screen, what dimensions you are using? Are you using the paper dimensions, this one, or are you using actual dimensions? This is my paper dimension and this is my actual dimension, let's say 1 kilometer. So what dimension you are using? I think you have started with the basic commands, line, rectangle, and so on. So have you drawn the rectangle, let's say 1 meter by 2 meters or 10 meter by 20 meters? What units you chosen? Have you chosen the units of paper or of the site? Site. So do you know that AutoCAD black screen indicates the real site? Okay. So whatever dimensions we are putting in the AutoCAD, they are real dimensions. That means that AutoCAD screen is an infinite space, almost. I'm not saying exactly infinite. And just a moment, what happened? Okay. So what we do in the AutoCAD, we draw it in the AutoCAD to the scale, side scale, and whenever we print on the paper, we give the scale to the print. So there is a print scale, and which is converting these total site dimensions into the paper, right? So on hand, by hand, how we are doing that we studied now. But AutoCAD doesn't understand, so we should give the scale to the AutoCAD so that we can print on the paper to this reduced scale. Okay, so this is the purpose of AutoCAD and how we can do. So how we do it by hand drawings and how we do it by AutoCAD, that is the meaning of it. Now let's move ahead. So let's say this is plot layout I have just shown you. So this same whatever I told you. So this is 5. So whenever you use this millimeter, then use millimeter on the scale also. Don't use centimeter or something. It confuses. We may get confused by this centimeter. If you use side dimension in millimeters, use on the scale also in millimeters, so that you can divide it properly. So this is also 1:200 scale. That means 5. This is for 1:100. This is for 1:200. Are you getting this? It's very easy, na? Yes.
Yes, sir. Yes, sir.
Now the question is, see, do you know screws are there in mechanical industries or machineries? We have the screw of 1 mm or something, right? Or 2 mm screws. So if I draw it the screw to 1:1 scale, it is very small. Actually, this is to the scale I drawn this. Can you see this? Diameter is 2 mm.
Yes.
But there is a star also in this screw, real screw. I cannot actually draw it because it's so small dimension that I cannot draw it properly. In such kind of smaller objects, we can use bigger scale, like 10:1, right? Are you getting?
Yes.
So this is generally used for micro objects. Your side dimension is smaller, but on paper you are drawing very bigger. So this kind of way we can do. Are you getting this? So you can show this thickness also 0.5 mm and smaller dimensions, so on, right? So this is the use of these scales. Now, yes, all of you know, tell me line types. Continuous lines or thick lines are used in drawings, where they are used. So this is a drawing. I'm just using this line. Okay, this is my continuous and thick line. Where it is used?
In structural, sir.
Yes?
Structural drawing and in AutoCAD drawing.
No, I'm just general drawing I'm talking, not structural drawing. What is the meaning of continuous thick line? This line is what is... So let's see, there are 3 types.
Border layout. Border
Continuous line,
drawing sheet.
center line, and dotted lines. Where center line is used, where thick continuous line is used, and where dotted line is used. Now let's think some different way. So whenever we have some objects, let's say, there is a hole in the object, let's say. If I see it from above, whatever I can see, I can draw it through very thick lines. And whatever I can't see, I should draw it dotted. Do you know this concept, dotted line concept?
Yes, sir.
This is the thick line which I can see through my eyes, which I can't see, but it is behind hidden behind. Then I can see it, I can use as a dotted line, right? And if this block is very symmetric, I can draw a symmetric or center line of this. That means I can understand that this is the center. See, as you may be saying that it is very simple thing, but I just don't want to teach you the things which are advanced, but you are not clear about the concept. So it is better start with the concepts only. so that no, everybody will be on the same page, right? And there is, see, this is the, so if I ask you to draw plan means what? If you look at the object from this, right? So
Top view, sir.
how can you see this top view? If I ask you to draw this top view, how can you see?
From, sir, we have to see from top, sir.
So will it be like this? I am telling you. Will it be like this? Yes?
Yes, sir. Yes, sir.
Yes, sir.
Are you, all of you are agree with this?
There will be the one line at the bottom.
There will be line at the bottom because this line is visible, right? Don't forget this. Correct. Now if I ask you to see this front view, how will it be?
There will be one box at the upper side.
Right? Is it okay? This front view I'm talking.
I don't think it has to be closed or the.
No, sir. Lines, sir. Line. Upper side.
Yes. Okay. Now tell me, if you see from the right side view, how will it be?
It will be
Right side,
rectangular
will
box.
it be like this?
Rectangular box.
Rectangular box. Yes.
Is it like this?
Yes, sir.
Yes, sir.
Are you sure, all of you?
Yes, sir.
Yes, sir.
I am saying no. What's wrong?
From the right side you're talking, sir.
Yeah?
Hidden lines should be there.
We can
There
From
is
the
a-
right side.
Yeah, from the right side. Will it be?
Yeah, exactly.
Yes. And if you go for the left side view, then I
Mirror
hope.
image of that.
Correct. So this is the meaning of dotted line, thick line. So actually this
Sir,
is called as,
it will be.
it will be?
Sir, actually, if we see from the right side, it will look like a box, no, sir. We have put this dotted line also.
This is right way, right side view, na?
Yeah, yeah.
Okay. From here I'm seeing.
If we see from the right side, we look it like a yeah from the right side.
Uh-huh. So is it okay?
It will be is it right? But what I'm asking is,
Mhm.
if we look from the right side, it look like a box, no, sir. A plane.
Yeah, it's a plane, but see, when in drawings actually we show some objects behind the plane also. We are not only concerned with this line only. So try to understand. We have to show certain objects behind that line also. So there is a limit, we can say battery limit, we can say.
Acha.
Within that, we should show all the objects. I'm not saying that everything you should till the end, but
Oh,
so because see in
okay, sir.
architectural drawings, structural drawings, you might have seen. Okay, so this is meaning by it is the meaning how to draw. See, read the drawings actually. To all of you,
Sir, this dotted line shows behind something is
yeah,
right side behind.
Something is hidden.
yeah, something
Yeah,
is there. There is
something
some
hidden.
hole. There is some hole. You can understand. Even though look at this block, you can understand there must be some hole kind of thing. Cut out. Right,
Okay.
cutout. You can understand there is a cutout.
Okay, sir.
Yeah, so when you read different kinds of drawings, then you will get that what is the meaning of this. Even though by looking at the drawing, you can understand. Right. Now, if I ask you, let's take one smaller example. I'm asking you to draw a 3D view of just a moment. Let's say this is a plan This is my plan of one object, and I am having one front elevation of the same object. Same. This is my elevation. Can you draw 3D view?
Yes, sir.
Tell me.
Sir, by putting a corner, one corner at 45-degree angle, then we draw all projection line through that angle, and then we join all lines. Then we get 3D.
Okay. Anybody else?
Isometric. I think it is isometric view.
Anybody else? Can you visualize what may be the 3D? I'm just drawing, correct me. Will it be like this?
Yes, sir.
Are you sure?
Yes, sir.
So that means this is my front view and this is my plan. So where is this?
No.
This will also. No, sir.
One small.
Will it be like this?
Yes, yes.
Yes, sir.
Are you sure?
No, there should be a hidden line.
So there, see, if I draw elevation now for this object, let's say, will be the this is, I'm drawing front elevation. Will it be like this? Front elevation? Yes or no?
Yes, sir.
Yes.
But where is this pole? It is behind, na?
Yeah, this is behind, so that's why there should be a hidden line.
So there should be hidden line like this. That means this is not matching with my projection. That means this view is not correct.
Yes, sir.
Yeah. So what is the correct? Which correct? That means this is also not single is not correct. This is not correct. So that means there should be some correct. There should be some different answer. Can you just mute? Somebody is having some disturbance. Hello? Some of you are having some disturbance in the sound. Okay. Yeah. So actually, it's a very tricky one. Many of you say those who are having. I think some first person who was calling that 45 degree something. Somebody was telling.
I, sir. Amarjit.
Amarjit.
Amarjit. Okay. So
Yes.
do you intend this? Okay. Do you agree with this view? This is the asymmetric view. If I see from the front, it will be seen like this. Even though I see from the, if I see from the plan, I can see this. And even though I see from front side, still I can see this. Right? Do you agree with this? Is it correct?
No, sir. No, sir. It's wrong.
It's correct, na? Yes or no?
But while seeing elevation, there will be the hidden line will be replicate over there, no, sir?
Where is the hidden line?
So at the elevation.
Actually, it is like this. Huh?
Okay.
It's
Then
like,
it will be better.
right?
Then it will be. Yeah.
Yeah. I'm right. It's not passing through. Okay, I'll correct it again. It's better to correct it properly. There is a plane like this. Okay. Now it's correct.
Yeah, sir. Yeah.
Yeah.
Now
Yeah.
this is imaginary with the
Right.
two diagram.
So this is. So yes, actually, my intention is to develop your reading skill, drawing reading skills, and this can be done only through practice and watching or visualizing different drawings. So whatever drawings you get, architecture, structural drawings, through your, let's say, references, so, and we are going to learn also in our training program. Read it carefully. Okay.
Okay, sir. Thank
Now,
you.
approximate scaling for hand sketching. Now, this is, see, as I told you, even though you are learning AutoCAD, you cannot.
Sir, one thing, sir. We
Yes.
draw 2D drawing in 3D, and that we have to go only two ways in isometric and axometric, no?
Yes.
And that is one is 45 and another is 60, or maybe I
Yeah,
forgot
yeah.
something.
Yeah,
I'm
45
correct, sir?
generally. Yeah, 45 generally we use.
Okay.
Yeah. 3060 is also possible.
Okay, sir.
Yeah.
Thank you, sir.
Thank you.
I think forgot these things.
Yeah. Now, approximate scaling for hand sketching. So this is very important. Now, in all over the world, there is a practice of using these kind of papers for the calculations, engineering calculations. So we also use, and even wherever you go in America, UK, New Zealand, Australia, anywhere, this kind of papers the people use. This is called as square rule pages. Square rule pages. Now you might have seen. Okay. Square rule pages. So those who are not really comfortable with the plain paper only, I would suggest use these square rule pages, because all engineers are using these kind of pages. Practicing engineers, I'm talking. The purpose of this is you get the reference while drawing. So you should not see, many people don't know how to draw a horizontal line exactly. So this goes like this. People are not comfortable to draw the lines by sketching pencil. So those who are finding difficulty, and let's say his vertical line is like this, or ऐसे कुछ तो होता है, ऐसे समझ में आ रहा है? The people really see, it is not necessary that everybody will be a say, we can say, artist. So artist can draws very smooth lines like this, but some person may be finding difficulty. So it is better to use these papers, so that I can just trace on the horizontal line. Let's say I want to draw a rectangle, use this, then use this. Okay. Now it is helping you to draw the drawing correctly. It's very easy, isn't it? And that is the benefit of doing the drawings on the square rule pages, first of all. Now, so use these pages, purchase these diaries or notebooks of this kind of, and you can do. So whatever practice you are doing in our training program, I would suggest all of you to take the notebooks which are square ruled. Okay. Now, approximate scaling. What is meant by approximate scaling? Whenever you draw any drawing, don't draw like this. Now let's see. Let's say I am drawing a drawing like this, and I say 4 meter by 4 meter is my rectangle. I'm drawing on the paper by pencil. Do you feel this is a really good sketch?
No, sir.
Why?
Because both dimensions are not same in papers.
So
Not
there,
permission as per the dimension.
Not fit in a skill, sir.
yeah, so as you have put the dimension correctly, yes, dimensions are correct, but it is visually incorrect. Visually, I'm saying it doesn't look correct, because see, do you know, our mind can understand the images and it can remember the images very well than words or numbers. Do you know this concept, or philosophy rather? Mind can read images and sketches very easily, and it can remember the sketches and images first than words and numbers. So if you, let's say I'm telling you this today, let's say there is a rectangle of 4 meter by 4 meter, or let's say, and I'm drawing, say there is a square of 4 meter by 4 meters, but you generally remember this shape. So whenever I tell you after 10 days or 15 days what I used, so you'll immediately draw like this, rectangle only, but actually it is a square. So whenever you do the drawings, please do it at least near to the scale. I'm not saying that you can draw exactly to the scale, because hand sketching is an approximate way. You cannot draw it. Otherwise, if you want to really draw perfect, then you should use the scales. But many times we need not to use the scale, because all sketches cannot be drawn by scale, but you can do it by hand. Let's say now I say that this is my 4 meter by 4 meter. Now, do you think it is visually correct? Yes?
Yes, sir.
Yeah. Now, whenever you use the sketching on the paper, I suggest all of you, you can say, now I want to draw a plot of, say, 50 meter by 100 meter. So I can assume that these squares are, one square is 1 meter. So 50 means how much? 1, 2, 3, 4, 5. Okay, so this is my 1, 2, 3, 4, 5. This is my 50, and then 10, na? 50 by 100 meters. So say 1 unit is 10 meters. Let me write the dimension. 50 meter by 100 meters. This is my site dimension. I want to draw it on the paper by hand sketching. 1, 2, 3, 4, 5. This is my 50 meter. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Now this is my right. So just mind me, I'm using this pen of this digital pen, so it may not be correct. Okay, so this is my 50 meters by 100 meters, and it looks correct, right? If you scale it, it will not be exactly 50 mm. So whatever you 50 meters, but it's okay. It looks very good, right? I'm just here to tell you the importance of these square rule pages. Correct. Here, this way you can use and improve your sketching. Correct.
Yes, sir.
So if you don't know this system, please use square rule pages, square rule notebooks for your calculations and drawings. All right, now let's move ahead. Now learn by examples. Yes. See, as definitely we are here in the training program. So generally how we learn the things actually, how do we learn the things? If I want to understand, if I want to take the knowledge to learn something, how do I learn? Any idea? So you can learn through reading the books, you can learn through YouTubes, you can learn through Google, you can learn through teacher, right? You can learn through observations, you can learn through listening. So there are different, we can say, tools which we are using. So eye is one of the important tool. Tool means our part, body part, by which we can learn. So eye means observation. Then we can learn through ear, means listening, right? And there is one more, that is touch. Touch means I'm using the pen and drawing. So pen, there is always this sense is also important, touch or skin. So I can use pick the pen and then draw it on the drawing paper. So these are the three senses actually through which we are learning the things. That means definitely we should use these three senses very effectively to understand and learn the things. So understanding lies within these parameters only and not in any software. Try to understand. Software is not helping you to learn or understand. These senses are using or helping you. That means as a civil engineer, fortunately, we can see a lot of structures surrounding us, buildings, bridges, and rooms, and there are a lot of things actually, bridges, all structures. Generally, civil engineering structures are easily available to see. That means we can learn a lot of things through only observation only. So don't forget, See, many times we are going through roads, on the roads. We are staying in our room, flats. But has anybody really tried to measure the dimension of door? Has anybody tried to see the lintel level? Has anybody really measured the dimension of windows, tiles? Anybody?
Yes,
Hello?
sir. Yes, sir. I have tried.
So yeah, so see, this is very important. Many times as a civil engineer, everything is actually near beside us actually, but we forget. So I would suggest all of you, all civil engineers, to purchase one measuring tape, 5-meter tape, let's say minimum 5-meter measuring tape. Always it should be with you in your pocket. Whenever you see some good things, some structures, take that measuring tape and measure it. So you'll learn a lot of things through measuring tape only. So measuring tape is one of the important tool we can have to learn a lot of things actually. So let's say you are moving or traveling on the road, measure the width of the road. If you are say in the parking, measure the size of the tile. If you are in the living room, measure the size of the tiles, doors, then seal level, then that's kitchen OTA height, and so many things. There are a lot of things actually. So this will let you know a lot of things. So 5-meter measuring tape will help you to learn a lot of things. And you will get a confidence that yeah, I know the dimension. See, how you get the confidence? Anybody?
By doing activities, by practicing.
Yeah, by action you get the confidence. So I am giving you the training. Yes, it is one of the part of the learning, but only getting the training is of no use. Don't believe me blindly. If I say the lintel height is 2.1 meter, take that measuring tape, go there in your room and measure it, and verify that it is 2.1. Once you verify it, then you become confident. Yes, I measured it on my own. Right? So this way you can do actions, exercise, trials. Do most of the trials. Even though you are wrong, still do the trials. Attempts. You should do more and more attempts. Then and then you can become excellent and confident. Right? So this is the meaning. Learn by examples. Real examples, I would say. Don't read the book and then say, tell me that 2.1 is the lintel height. Don't read book. Huh? If I ask you what is the size of the brick, anybody knows this size of the brick?
Yes, sir.
Tell me.
9 by 9 into 10, sir.
9 by? Tell me the units also.
Sir, actually in the code, sir, 20, 10, 9. But in the practicing sites, sir, generally you getting 10 inch by 9 inch by 3 inch, sir. Okay. Yes.
Now,
And,
whatever you are saying,
no,
have you really
not-
measured this dimension?
Sir, 10 inch in the site, sir, 10 inch by 5 inch by 3 inch, sir, in the site.
So whatever you are telling, have you really measured using measuring tape, the real brick?
Yes. Yes, sir.
I'm not confident. Actually, my intention is asking to this question is not that you should tell me the answer. My intention is whatever dimensions you are talking, please verify on the site, and then you can really be really confident. Yes, I measured it. I can show you. I can show you the bricks. Yeah.
19 is 10, and instead of 9, 5 and 3, sir. 10, 5, 3. Generally in our
Okay, see, have you really verified? I am not sure because the dimensions, I don't agree with this, but it doesn't matter. Here we are not here to ask the question and get the answers. Here we are here to understand that we should measure it on the site and then tell me the size. Okay, so all of you, please measure the brick size whenever you get any opportunity to see that brick, and take that measuring tape and measure it. So these kind of measurements you should know as a civil engineer. It should not happen that some unskilled person is asking you some questions as a civil engineer and you don't know the things. At least common things you should know, right? Try to understand the concept of asking this question. Drawing presentation is very important. Definitely, as I said, if you draw this like this and 4 by 4, it's not a good presentation. If I say there is a vertical line like this, is it really good presentation? Is it a vertical line? It's not good presentation, right? So the drawing should look visually correct. So presentation is very important. As you are doing the drawings in the AutoCAD, it doesn't mean that you can understand the drawing easily. Yeah? See, AutoCAD is a tool. You will learn the tools, and that tools what we are telling you in the training program. We are telling that tools only, but these are the sessions which will be helpful for you to understand the drawings also. So presentation, it should look really beautiful as an artist, I would say. I'm using the word artist because engineering drawings should be drawn like artist. If you look at the drawing, you should really feel very good. So this is very important. Drawing balance, yes. Now, what is meant by drawing balance? Anybody knows? What is meant by drawing balance? Drawing balance means something.
Balancing the error while drawing plan, maybe.
No, that balance I'm trying to ask you, that visual balance. Let's say I'm doing the drawing here, here, and then there is a text.
Yes.
There is a table like this in the drawing, like this. And there is a heading plan, and there is heading schedule. Okay. Then I am writing here some notes.
Scaling.
There is this, and this is my drawing. I am telling you, please do the construction on the site. Is it really looking good drawing? Huh? Is it really good?
No.
When nothing, this space is unnecessarily blank. This space is blank. This object is here. This is small object. Wow, how you are doing? It's really not good drawing, and it's not looks good. So presentation is important. Don't do the drawings as you like, as you. Let's say then I'm trying to. There is a plan of a building. So please, there is a plan of a building. Then there is second floor plan of the building. Let's say I'm considering the building plan. Okay. Then there is a section of a building. Let's say this is a section of a building. This. Then there is a schedule of drawings. Schedule of, let's say, columns or beams. Okay. And there is a kind of table like this, let's say. Then there is some blow up. There is a blow. Zoom scale, zoom to the scale, let's say. Then there is a title block over here. So mind me this vertical lines. I'm not in a position to draw it through this digital pen. Then there are notes. This. Then there is a title block, drawing name, client name, like this. Getting? If you look at this, then it looks really balanced drawing, isn't it? Try to understand my intention. Huh? See, it is not really good drawing, but still, do you think it is better than the before?
Yes, sir.
Yeah.
Yes, sir.
Try to understand that it is now visually balanced. All objects are arranged in a paper such a way that they'll look really appropriate. That is called as the visual balance. So balance of the drawing. And drawing types, there are different drawings, isometric drawings, then plans, elevations, sections, architectural drawings, structural drawings, mechanical drawings, and so on. Now, pen thickness. Has anybody really drawn the drawings using the rotary ink pen previously in the college or in the practice? Yes. Rotating ink pen.
No, sir.
Rotating. Okay, now you are in, say, very early technological age actually. This is now, it is almost obsolete. Not exactly, but yes. So this,
First time
what is meant by point thickness, pen thickness? So in engineering drawings, which we used to do in 20, 25 years back, 30 years back, generally there were no any printers available in those time. So there we used to use different pen thicknesses, like 0.6 mm pen thickness, that 0.5 mm, 0.4 mm. You may be knowing this 0.5 mm pencil. Okay, so you may be aware of this. So these were the rotating penning thicknesses, and these we used to use for different line types. Now you can see here in my this box, this is my one single line, then there is, I'm using this. So even softwares nowadays are using this kind of thicknesses. Even AutoCAD is also giving this thick line, thicker lines, thin lines like this. Are you getting? So we can use different pen thicknesses in our drawings. Even though we used to do it in our hand, say hand drawings, we are using it in softwares also like AutoCAD. So don't forget, because otherwise if you don't use different pen thicknesses, it will not really look good, right? So these are the thicknesses used. You'll come to know, I think, in AutoCAD also. But this is the system done manually also. Now try to understand what I'm trying to say. So that means, let's say, what I want to say by this, let's say, okay. Now there is a column I'm drawing in plan. So have you seen any structural drawings previously? Anybody?
Yes, sir.
Yeah, so those who have seen the structural drawings, let's say, generally columns are shown like this. Okay, by many consultants. Can you see the thickness? Outer boundary is thick and this cross is little thinner, right?
Yes.
Does it look good? I think so. So generally in architectural drawings, structural drawings, the columns are shown like this. This is the better choice. It looks really good because whatever are the prominent objects in the drawings, they should be shown bold and thicker. If you do the drawing only by like this, by using single pen thickness only, it really doesn't look good actually. I will show you some examples of the drawings. So that is the importance of these pen thicknesses. I would suggest all of you may be staying in a bungalow or flats or something. Draw architectural drawing of house by hand. You may be surprised that we are taking the training of AutoCAD and I'm asking to do this by hand. But yes, you should do this. Okay. Whenever you find time, please do this exercise. My intention is not to get the correct drawing. Definitely not. Correct or exact. This is not an exam. Huh? We are not giving any marks to you, but the procedure which you will do, the journey which you will pass through while doing these drawings, you will learn a lot of things. And put the dimensions, measure it by your measuring tape, all objects. You will learn a lot of things if you do this exercise. I don't say that you do it within 1 or 2 days. Whatever time you get as per your time availability, plus complete this assignment. Let's say 5 days, 7 days, 8 days, whatever it may be. You will learn a lot of things. So this is your exercise to you. Then discuss on different architectural structural drawings, create questions, discuss your observations with respect to drawing presentation. Whatever I have told you, please embed those concepts into your drawing. Okay. Are you getting this? This is your assignment. So as an architect, so as if I would say you are an architect drawing the as-built drawing. Do you know as-built? As-built drawing. Do you know this word, as-built drawing?
Yes.
What do you understand?
Drawing
For the concept,
Yes. As built means it is already built. You are drawing it again. Actual drawing, side drawing. Okay, as it is, as it is. That is as built drawing. So please draw the as built drawing of your house, whatever may be the house. Please take the measuring tape. Purchase this. This is a good investment of purchasing a tape as a civil engineer. Okay. Then definitely, what are the objects in drawing? You are learning that line, rectangles, polygons, circles, hatches, and so on. So that is going on in your AutoCAD training program. Now I will just before the structural department flow. I don't want to go here. Yes. Let's see. Sorry. Can you see the screen?
Yes, sir.
Yes, sir.
Please discuss me about this. What do you see in the drawing? This model or 3D view. This is a 3D view of a building. Any observations? Vague observations also is fine. See, don't see the questions which I generally ask you or the questions which we generally discuss. My intention is not to get the right answers. Try to understand. Generally, we in the colleges we are taught to give the right answer. If you give the right answer, then you get the 100% marks. If you don't give the right answer, then you are wrong and you are fail. See, this is not the practice. And in practice, we cannot follow this kind of procedure, and this is of no use. All theoretical academic exam systems are not so much useful. I'm not saying that they are useless, but not much useful, I'm saying, because we are taught to give the right answers. But in practice, I would say, whenever you try it first, then what will happen after trial? You will fail somewhere. You will be partially correct, then again try, then you will again fail somewhere and you will be better partially correct, again try, and this process at the end will give the appropriate answer. I'm not saying correct answer, because there is no as such correct answer in life. Appropriate, I would say. That means, or acceptable answer, let's say. I can accept, not a bad. I'm not saying that acceptable means very much correct. Very much accurate is not a really, I don't believe in this accuracy, 100% accuracy. We are tending to the accuracy, trying to reach to the accuracy. Trying to reach the accuracy. That doesn't mean that you reach. And I don't want to reach also that accuracy, but I am trying to reach, definitely. So trying to reach me is a journey. And for journey, you have to do a lot of efforts and actions and trials. So I would say you should try a lot of things. Try it, act it, even though you fail it, just again try. So my intention is, whenever I ask you such kind of subjective questions, do you know subjective questions? Anybody, what is meant by subjective questions? Anybody?
You have to provide explanation.
Subjective and objective, let's say. Objective means what and subjective means what?
This is a subjective question. You have to explain something. In objective, we have given the choice.
Yeah, actually, I'm asking a little different. Subjective means I know this. You are giving the answers as per the academic understanding. My meaning of the subjective means the question which has different answers. Okay, maybe having many answers. A1, A2, A3. There are a lot of answers to the same question. That means it is very subjective, na? Let's say one person is giving me these answers, second person is giving me this answer, third person is giving me this answer. Can I say that this is giving wrong answer and this is giving me right answer, wrong and right? There is no competition of the right and wrong. So this question itself is a wrong question, because it's not wrong question, it is a subjective question, which can have different solutions, which can have different answers to that question. And this kind of question I'm asking you, whenever I ask this kind of question, whenever there is an objective question, that means if I ask you question, what is 2 into 2? What is this answer?
4.
Will it be different for all these people?
No, sir.
No.
No, sir.
Because it is objective question and it
In
has to be
general-
exact. Some mathematical calculations or some logical calculations, they are most of the time objective questions and they have to be exact answer. That means this is your final destination. But in subjective questions, there is no final destination, but there is a near to the real answer, we can say. Near to the real. Near means it is not exactly real. So try to understand, in practice, whenever we take the decisions on the projects, we generally follow this subjective part. Definitely, so objective part is most of the times involved in the mathematical calculations. But still, we are doing the mathematical calculations for the subjective problems. So try to understand this now this term is maybe little new to all of you, but try to understand. So please think in this direction. Your thought process has to be aligned in the subjective direction, because for that you need to break this, whatever patterns you have learned in the academics till now, gradually try to break this, and then you can understand what I am to say. And this is the important thing which we can use in projects for decision making process. So you can get good decisions, quick decisions, appropriate decisions only through this subjective methodology, right? So okay, now I ask you, what do you observe by this? What are your observation in this view? Please. Yes.
Hello. Sir, I observed that client how to use that small piece of land either to build a residential or commercial building. If as I observed here is a residential building where residential building up to 3 floor, 3 floor, 1, 2, 3, and top floor, fourth one is top floor, and where the client uh, provide the opening, and the opening is how much far from the main road, and where they have to place garden area and parking areas. Also these things I have to observe. And the front face how looks, the front face of this residential building how looks like, all
Yes.
these things we have to observe.
Yeah. Anybody else?
Yes,
Yes.
sir.
Hello. I'm listening.
Hello. Yes, sir. First of all, from the picture, we can see that it is a stilt plus 3 floor building. So the parking is provided at the ground level. Then we have 3 floors, in which both sides there is balconies which are coming out, and these are covered with some walls also with them.
Yeah.
And from the the base we can also see the columns, and possibly the staircase will be in the center,
Yes.
and rest is the elevation, and rest is I think they have provided wall for the elevation
Yeah, yeah.
in the front.
Yeah, yeah. So whenever we observe anything, observe as it is, as it is. Something which you cannot see, please don't discuss, because you cannot see, then how can you say that it is like? Now, somebody has said, see, don't take personally. Yeah? Whenever I discuss, there is no question of pointing anybody, but we are trying to develop our thought process, right? And this is still subjective, because it doesn't mean that whatever I'm saying is 100% correct. Developed a thought process. So client might have used space optimization or that utilization. Might have, we can see, use the word might. You cannot say that it is he has used optimization. Now, yes, there is a possibility of staircase over here. Yes, there is a Yuko. I think. Can you just mute yourself? Yeah. So there is a possibility of staircase. Then you can say, I can see the elevation color is gray color. Why not to start with very simple things as it is? It looks, there is a glass to the window. There is a glass. There is a window like this, corner window, 1, 2, 3. Yes, I can see the gate. I can see the car. You should see all the things surrounding also. And then there is a gate. Then there is flowers. And yes, there are some columns I can see. This is one column, 2, 3. Whatever I can see, I can just see that only. So it seems that there are some columns like 1, 2, 3, 4, 5, 6, and maybe other columns behind that. I'm not sure. There is a window like this. Yes, there is a balcony. It seems there is a balcony. Now you can judge a lot of things, but you should verify. Actually, whenever you see the site exactly by visiting the site, definitely you will understand. But you can judge also. Whenever you judge, there is always a possibility of doubt that your judgment may be correct or wrong, both. There is a balcony. Is it a balcony or is it only railing? If it is a staircase, there is a possibility that it is only railing for safety purpose. That means it may not be the balcony. It is only railing for safety purpose in the staircase premises. Then what you see, okay, so you said parking plus 1, 2, and 3 floor, and there seems to be a terrace over here. Some, maybe it may be cover of the staircase cap. We can say staircase cap. It may be a staircase cap. I think so. Generally, architects gives the elevation to the staircase cap like this. Okay. Then there is a compound wall you can see over here, right? The trees are there. Okay, fine. There are trees. So this way you can understand. Whatever you can observe as it is, you can comment. Now there are two things you can observe as a common person, where your engineer is not in picture, common person. And then you can observe as an engineer. So there are two things, don't forget. Now generally, whatever common persons can see, we call it as a common sense. Common sense means any kind of human being can see the same thing. If he sees the gray color, definitely you can also see the gray color. It doesn't mean that engineer is seeing some different color. Common person is seeing as a different color. No. If you see this as a glass, definitely common person also understand the glass. But what engineer can see in this? Now tell me, what do you see as an engineer, or what do you know as an engineer in this building? Probably.
Dimension of column.
Yeah, some dimensions you may be aware of it, right? So if I ask you, what is this dimension? Probably you should verify it in the drawing, huh?
So
But probably
3 meters.
how
3
much?
meter.
Probably 3 meters.
3 meter.
3 meters.
3 meters, sir, 3 meters.
Or
Please look carefully.
2.75.
10 feet. 10
Please look carefully. Carefully.
2.12.
Where is the floor?
Yes, sir. No, sir. It is a 2.7
It is
meters,
2.1.
2.1. Yes, it is a lintel, na? My floor is
Yeah.
where? Somewhere here.
Above.
Right?
Below
Yes,
the
this is my floor level. This is my floor level. That means This is my lintel level, right? This is 2.1, and this may be floor to floor, maybe roughly 3 meters, let's say. Generally, our flat schemes are 3 meter floor to floor height. Now, this you can see as an engineer, but you are only judging. This is not exact dimensions. Go on the side, take the measuring tape, and then check it. We are generally judging it. When I say judge, it is not 100% correct. Judgment is judgment. It is near to the judgment means what? Near to the answer, but not exact answer. How will you find the exact answer? How to find the exact answer?
Structural.
After verification.
Go on the side, take the measuring tape and measure it. Exact answer means you should see it exactly. Yeah. So these are the things you go take the measurement tape and go there and check it. But yes, as per our experience of the different projects, this is generally 3 meter. This is generally 2.1 meter. What do you call this as? What is this height we call it as?
Sea level.
Sea level. So this is sea level and this is sea height, we can say. Okay. Just a moment. Okay, fine. So whatever philosophy I just told you, try to understand that. You can utilize this thought process everywhere. Don't believe. Whenever I say don't believe, this is very good word. Once you don't believe, then you can definitely verify it. If you believe somebody and somebody is saying something wrong, you may be confused or you may be wrong sometimes. Okay, so this is my discussion regarding the observations. Now, have you seen any submission drawing, architectural submission drawing previously?
Yes, sir.
Yes. Now you should actually read different drawings. So submission drawing is different. Working architectural drawing is different. And the different objects are there, different things are there. Let's say this is a submission drawing of an architect where there is a ground floor. He has written the scale as 1:100. Then they give the marking as a north side, which is the north. Then these are the lines, dotted lines, then dimensions are given, then rooms, setback distances, then first floor plan, architectural plan, this is architectural drawing. Then second floor plan, then this third floor plan or terrace floor plan. Then they are showing some car parking dimensions, scooter dimensions. Then they show the area statement by triangulation method. Okay. So these are the drawings types. Architectural drawing. These are the area calculation drawings. Only rectangles and triangles, and we can calculate the area of the drawing, that plot or built-up area, plot area, something. There is a site layout, site location, we can say, location plan.
Key plan. Yes, sir.
So yeah, so location plan. Generally, it is not to the scale because we cannot draw it to the scale actually. Location. So there are some drawings which are given to the scale, and there are some drawings which may be some not to the scale. So area calculation can be drawn not to scale. Not to scale means I need not to specify the scale. Yes, generally it is drawn to the scale only, but this is not exact 100 or something. It may be something different. There are some other drawings like this compound wall section, some details. So try to understand this, what I'm to say. And then there is a title block. Who is the client? Who is the architect? What is the project? Who has drawn the drawing? What is the scale of the drawing? North, revision marks, and so on. You'll come to know this gradually. I'm just giving you, this is only starting sessions, just to be comfortable with the drawings. Then some tables, legends, door sizes, FSI calculations, area statement. So these are the drawings, then elevations like this. So these are the drawings. Now you can see the dotted lines also somewhere he has drawn. See, these are the duct dotted line he has shown. This is the staircase dotted line. Do you know what is the meaning of this dotted line in the staircase? Any idea?
Yes.
Yes, please.
Yeah, this dotted line shows above the cutoff line, the staircase goes up. It is above the cutoff line.
Yeah, let's say mid landing and little at mid landing level. If I see the plan, then only this portion can be seen, and above it will be dotted line like that.
Yes.
So read the drawings very carefully. If you have the example of drawing, I'm going to share you in the study material on the classroom. Are all of you joined to the classroom? Are still pending?
Yes, sir.
Yes, sir.
So we are going to upload the study material and whatever these sessions which we are discussing with you, so that you can study at home.
Okay, sir.
So please do read it carefully. See, now training process is a two-way process. Only we are not teaching you or training you. You are also supposed to learn and study the things and practice. So this is one of the drawing. Then there is one more drawing I'm going to show you the structural drawings. Let's discuss on this. This is a first floor structural drawing where we are showing the beams, columns, staircase. Can anybody tell me what is meant by this dotted line? Or why it is dotted?
Sir, this is sunken area, sunken slabs.
No, this dotted line I'm talking. This one.
It's a beams hidden line.
Why it is hidden? This line.
I think it is with the slab.
They are below the floor.
Attached with.
Whenever I see the plan, where I see actually, let's say this is my slab which is casted today. Let's say. And if I see the slab from that top view, let me draw part plan actually only. Let's say I am drawing the section like this. Oh, what is this? Let's say I am drawing the section like this. How will it look like? Let's say to the right I am having a beam, then I am having a slab, then still I am having a beam, then I am having a, and this is cut out. Okay. So this is my B1. This is my B4, right? Now I am looking from this. Correct? When I look, this line is very easy, visible clearly, so it is thick. This is thick line. Is it visible? This point is visible from top?
No, sir.
No, therefore I have drawn it dotted.
No, sir.
Now here you can go for B4. Can I see these two lines, these points from above? No.
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 So both are dotted. So try to understand these minute details in the drawings. So as our training program, yes, definitely you are going to learn a lot of softwares, but I give emphasis to the engineering understanding. I would say, even though you don't learn too much of softwares in our training program, but if you become a good engineer at the end of the sessions, I will be a very happy person. So our aim is to become a great engineer through this training program. In that, it may happen that you may not be very much expert in the software. And even I don't expect. Expert. Yes, you should know softwares, basic softwares, and you should use the softwares as per the practical project requirement, and that's it. But if you become the great engineer by this kind of engineering understanding and concepts, then there is a real engineer, and you will enjoy this actually. So whatever profession we are in and whatever training program you are in, I would like all of you to enjoy this. And this enjoyment only comes through the conceptual understanding, right? So keep this in mind. This is very, very important point. If you enjoy your work, your career, then it is a really good, because you know that we are almost spending 33% of our lifetime in career. We are spending 8 hours for sleep, almost 10 hours in the office, 8 to 10 hours, 2 hours in traveling. How much is remaining for family? Let's say 24 hours only for family. Let's say personal life. That means most of the portion, most of the portion goes in the office, in the career, in the offices or whatever. That means definitely you should enjoy this, isn't it? So this is very important. You should enjoy your office work or at least your engineering. So keep this in mind, and that enjoyment comes through the basic concepts, basic understanding of the structural engineering or whatever civil engineering you are working in. So that's it for today. We can discuss. See, now hence onwards, I'm going to take some few sessions before going for the actual, say, software study. Let's brush up some engineering concepts which we learned. Get comfortable with the engineering concepts, and then we will switch over to the software and so many practical projects and so on. So I think that's from my side. Any questions from all of you?
Sir, one small doubt.
Yes.
Sir, regarding these dotted lines, can you please explain once again in the elevation you have drawn recently?
Yeah.
These dotted lines.
Have you section is clear to you or not?
Sir,
So let's say
section
this.
is clear.
Yeah, this is
Section
my
clear.
section A. I'm looking from this side. That means on the right side there is a B1.
Yes, sir.
Now, when I see this line is clear to me, right? So there is a building, maybe building like this. So this is clean line. So is it clear? This is a thick line.
Yes, sir.
Now, whenever you see this line vertical, it is behind. Due to this slab, I cannot see this, but there it is there, na?
Yes, sir.
So this is a dotted line. And once you see this before, then both vertical lines are not visible from this side. Only I can see this plain slab. That means these two lines can be seen through these two dotted lines, right? Okay.
Okay.
Yeah. Now you can see this. Now let's say, okay, I'll just remove this. Now if I ask you, why this is thick line? Why it is not dotted line, even though there are two slabs? If I draw the section like this, then this is B17. No.
It might be a duct.
It is a sunken portion, sunken slab in the toilets. So this is my actually, and this is my S2, this is my S1, this is my B17, this is my B20. Now if you look from above, these two lines are visible clearly, so B20 is clear. Now actually this is wrong, huh? I think this drawing is wrong. It should be thick. See, many times engineers, draftsmen do the mistakes like this. Okay. This is a thick line, yes or no? Because staircase is open.
Yes.
Do you agree?
Yes, sir.
It should be very thick line, right? Yes, really like this. Okay, now my presentation is correct. Now these two lines are thick, so B20 is clear. This is thick, I can see this line, right? So this is thick line, and B17, this is not visible from top, so it is dotted line. Are you clear about this?
Yes, sir.
Yeah, so actually today's session is to understand the drawing concepts, drawing reading, different dotted lines and line types, how to observe, how to listen, and how to get the knowledge from the surrounding, from observation by reading, we can say. So read number of drawings, whatever possible you can get. We will be also sharing you, but at least read those drawings. Observe the structures which are available beside, near to you, your flats, your buildings, roads, and everything. So that is the intention of today's session. Okay. So that concludes my session. So thank you to all of you.
Thank you, sir.
Thank you.
Thank
Yes,
you.
sir. Thank you, sir.
Thank you. Good night to all, and we'll meet, let's say, day after
Thank you very
tomorrow.
much, sir.
Good
Okay.
night, sir.
Good night.
Okay, sir. Thank you, sir.
Good night, sir.